Okay, assalamu alaikum everyone, and welcome to this series of the video lectures, starting with the first lecture, that is today. So as far as we learned or studied in previous lectures or in the previous chapters, so whatever we were doing was summarizing the available data that we had from some past events with us. We were just making or analyzing that data using some sort of fancy frequency distributions or making different type of charts, only to make sense of that data or get the required information out of that. Now in this part, the thing that we are going to learn is to study or learn about the chances of something that would probably happen in future. We are going to learn something new which comes under the category of inferential statistics or statistics of inference. We obviously are not going to study inferential statistics now. That would be followed by this course of yours. That would be the next course taught in next semester to you people. But the thing that we are going to start now, or we are going to learn now, is only that which would help us to minimize that risk of failure, to minimize that risk of loss while we are making some future predictions, while we are making some future claims, or while we are planning to make conclusions for the things that would happen in future. That thing that's going to help us reduce that risk is called probability theory, which we are going to start right now. Probability theory, which often is called the science of uncertainty also, is a very helpful thing, is a very useful thing that gives us or enables us to have a logical approach towards the things that we are dealing, to see all the possibilities for that particular situation, for that particular scenario, so that guessing about that thing becomes easier. So when we are starting with that, we would first try to learn about the basic terms which would help us to go smoothly in the theory when we are learning it further. So starting with the definition of probabilities itself, we say that probability of anything is nothing but just a numerical measure of how likely that thing is to happen. Like if I am starting to a new business, the probability for that business to get established is nothing, just the numerical value of the chances associated to the establishment or not establishment of that business in the future. If I say that there are 70% chances, it means I say that the probability of my business to get established is 70%. Or what other measure of probability are, we would surely be discussing in after some time, that okay, how I can write 70% in other ways as well. So when I say that 70% chances are there, I'm saying that there is 70% probability that my business would get established, or I'm saying that there are 30% chances that the business would not get established, or the probability of not getting established is 30%. So probability just gives us the numerical value, the numerical measure of how likely that event is to occur, that situation, that condition, that scenario is how likely to occur, to get established, to run, or to take place. Then when we are talking about the probability of things, definitely we need the things first. We need to know about the things first. There would always be anything under discussion for which I am trying to talk about its probability. There must be something under discussion of which I am going to decide the chances, I am going to predict the results. Say for example, while talking about the business idea, The possibilities for me for that business plan are that either I would succeed in it or I would get a bad failure, or maybe an option in between this as well, but right now if I'm considering these two options. Similarly, if I'm talking about the weather of the next week or for tomorrow, maybe I have the options that either it would rain or it would be dry. Similarly, if I take a very simple sort of problem or sort of thing, activity, that I am tossing a simple coin, the possibilities or the options that I would get is that either the coin would give me a tail or it would lay a head, or if I am rolling a die, the simple possibilities would be that the face of the die would bring me a single dot, 2 dots, 3 dots on the face, 4 dots, 5 dots, or some 6 dots on the face. So these can be the possibilities when I am rolling that particular die, or these can be the possibilities when I am tossing a coin. I can't have any other options, or this would be the possibility for tomorrow's weather, or this can be the possibility for my business, which I am trying to predict whether it would get established or it would bring me a failure. So whatever these situations are, whatever these scenarios are, these things are named random experiments in the language of probability theory. Now what we mean by random experiment? The random experiment is an activity, is a procedure, is a thing that generates you the possible outcomes which are already well defined, which are already pre-defined. Like I have some well-defined outcomes already for this activity. When I am tossing coin, I am pretty much clear in my head that the only possibilities are that either I would get a tail or I would have a head. I am not clueless about the thing that okay, after tossing a coin, I don't know if it would start raining. I would never say that okay, after tossing a coin, the flowers would come out of the would start coming out of the ground. That's not a possibility in my mind, or my mind is not clueless that what would happen once I'm tossing the coin. Similarly, once I'm rolling a die, I'm already clear that the possibilities would be one of these. Like the die would bring me a single dot on its face, 2 dots on its face, 3, 4, 5 or 6 dots. So the random experiment is an activity which generates any of these outcomes which are already well defined. We know those outcomes before getting into that experiment. By saying that we know these outcomes before getting into the experiments, I really don't mean to say that we know the chances of them. We know that these are the only possibilities, but we don't know that how likely is it to bring me a tail, how likely is it to come ahead on the face of the coin. I'm not saying that we are sure about the outcomes that would come forward. We only know the possibilities of them, that the only possibilities are these two. We are not sure about that how likely is it to become a tail after the toss, how likely is the coin to get a head after the toss. That thing we are heading to learn in the probability theory. Once if I were sure that it would be a tail, 100% sure, or I knew that it would be a head, then what's the purpose of discussing all these things? So the possible outcomes are predefined, they are well defined. I know that what would happen, what are the possibilities, but I don't know that how likely it is or what would exactly happen when I am doing that toss. Now the next thing that we are going to explain is these possibilities, these possible outcomes. each of these possible outcomes is either called the experimental outcome, or more precisely it's called a sample point. So for coin tossing experiment, I have two possibilities. Either I can have a tail or a head, so I can have two sample points for it. For rolling a die experiment, I can have 6 sample points, that is I can have 6 possibilities that it can either give me one of these outputs. Then once we are clear about the sample point, we say that if I collect all the sample points for any particular experiment, like for the experiment of rolling a die, if I take all the possibilities, that the only possibilities are getting 1, 2, 3, 4, 5 or 6 dots on the face of the die, then this collection of all sample points is called sample space. Sample space for the experiment of rolling a die. Similarly, if I take all those possibilities or both of these possibilities for tossing a coin, I've got the sample space for tossing a coin once. Like when I toss the coin, none of the outcomes would be out of this. Nothing would happen beyond this. The outcomes would surely be one of the two outcomes that I have specified here. So we just learned that what the random experiment is, we learned that what sample point is, what sample space is. Next, if we move ahead, we would talk about events in the probability theory. That what do we mean by that? Here I would discuss some very basic example. If say for example we are tossing a coin for 2 times repeatedly, like I toss it for the first time, and after first toss I toss the same coin for second time, or I am having 2 coins and tossing them together. Take whatever example you are convenient with. So for the first toss, the possibilities, the possible outcomes that I have is either that first toss would give me a head, or that first toss would give me a tail. I don't have any option other than this. Then once I have tossed it for the first time, when I am tossing it for the second time, the possibilities are again the same. Once I got head on my first toss, after that head, again I can either have a head on the second toss, or I can have a tail on the second toss. So the possible outcomes would be I got head on the first toss, then that head was followed by the second head on the second toss, or I got head on the first toss but that head was followed by a tail on the second toss. Similarly, once if I got tail on the first toss, on the second toss I can either have a head or I can get a tail again. This would give me the possibility that I could have tail on the first toss followed by head on the second, or tail on the first followed by another tail on the second toss. So this was my first step while doing the random experiment. My random experiment was tossing a coin 2 times. This was my random experiment, and that random experiment had 2 steps. The first step was the first toss, the second step was second toss. There were 2 options for my first step and 2 options for the second step again, and the total possibilities that I got are either having both heads, a head then a tail, tail and a head, or 2 tails. So as we said earlier that this collection of all possibilities would be the sample space for me for this particular experiment of tossing a coin 2 times. This this possibility and this possibility particularly individually would be termed as a sample point. This is a sample point, this is again a sample point, and so on. But if I explain some additional thing, that I am interested to see that the situation where both heads are occurring. So I have specified a situation additionally. That situation is having both the heads. So the option satisfying it, or the possibility for it, would be HH. We call it a particular event. It is that I defined some particular event which says that how likely it is, or what are the situations where I can have both the heads. Similarly, if I say that I can get, or what are the cases where I have at least one head, that situation can be satisfied by these options, that either I have a tail then a head, I can have a head then a tail, or I have both the heads. In all the situations I at least have one head, and I would name this as an other event. So by events we mean that events are some additionally explained or additionally defined situations which are satisfied by some of the sample points. So we would say that the collection of some sample points make an event. That collection can have one sample point, that collection may have more than one sample points, that collection may have no sample point. Say for example, if I am dealing with the same coin tossing experiment in which I am tossing a coin 2 times, but I define an event that what are the chances that of having 3 heads. Leaving away the chances situation, because I'm not assigning the chances or the probabilities right now. If I say that which of the situation can be represented, can these points represent if my situation is having 3 heads, so there obviously is no sample point available for me which can fit to this situation, because the experiment contained tossing a coin 2 times, and in 2 tosses I cannot have 3 heads. So this cannot be satisfied by any of the sample points. I would call this a null or an impossible event. Again, this is an event, but it has got no sample points. So the event is simply a collection of some sample points. That collection may have one sample point, more than one, or have no sample point, depending on the definition, that how it is defined. Next, after events, when we define the events, sample points, sample space, and all the things, the next thing that comes into the, which we can in accordance to this explain here, that this sort of illustration which we just did here is named the tree diagram. So I was explaining the coin tossing experiment, and I took the help of this sort of illustration, which was illustrating the options, the possibilities for the first experiment or the first step of the experiment. Then it was showing the possibilities and options for the second step of the experiment. This kind of graphical, this kind of pictorial illustration is called the tree diagram, which is very helpful in bringing forward all the total possibilities for particular experiment. But it's really very helpful, but not very convenient in the case when we have an experiment which has lots and lots of steps, or an experiment for which the steps have really huge number of outcomes. Say for example, if I am talking about or dealing with the experiment that is tossing a die, rolling a die. So the die rolling experiment would give me some 6 outcomes, I know. If that experiment is rolling a single die or rolling a die for the first time. So it can give me 1, 2, 3, 4, 5 or 6 as said earlier and a number of times. But if the experiment is rolling a die for 2 times, then once I rolled it, I could have these 6 possibilities. But again on the second step I have 6 possibilities. If the first time, the first step, the rolling for the first time gave me 1 as an output, the following step can again give me the 6 outputs. Similarly, if it gave me the outcome of 2 digits on the face of the die, the second step can again have any 6 possibilities. The same thing would go with this and this one. So this would become very tedious. This would become something like a very messy picture, which would be hard to get well with. Or if, say for example, I even make a third experiment, a third step, third roll of the die, it would even become messier. So tree diagram strategy is helpful when we are trying to make sense of all the possible outcomes. But in the case it has either many steps, I'm performing that experiment in more and more and more steps, or I have more options for a single step, that becomes a really complicated or tedious thing. Now once we know about the definition of probability and that these basic things, then comes the thing to start assigning chances, assigning possibilities to the available and the possible outcomes. Once I come to know that how many possible outcomes are there, the next task is to assign the chances, the possibilities, the probability to this chance, to this outcome, not to this chance, to this outcome, to this particular outcome, to this sample point, and so on. So before getting into the situation, before getting into that thing, when we are assigning the probabilities and we are distributing their chances, that this particular chance is for that situation or for that sample point, it's very crucial to have an idea of the number of those possibilities. Like if for the tossing experiment of coins for 2 times, unless and until I know these possibilities, I'm not able to assign their respective probabilities. If for single toss of the coin experiment, if I don't know that how many outcomes I have, if I am not aware of the possibilities that either it would be a tail or a head, if I don't know that thing, I can never ever assign the probabilities that how likely it is to have a head or how likely it is to have a tail. So before getting into the situation when we are assigning the probabilities, it's necessary to have an idea that how many outcomes are possible. And for getting into that thing, we use the counting principle. The counting principle simply enables us to know all the possible outcomes in total for any experiment that we are doing, like without getting into tree diagram or without getting into any other thing. So once we do the counting principle, starting with the first part, that is the counting principle or counting rule for multi-step functions or multi-step experiments. So as we saw just right now, that if I am dealing with the experiment that is tossing 2 coins or tossing a coin for 2 times, this experiment operated in 2 stages. It went in two steps, and those steps was, the first step was toss 1 and the second step was the second toss. Now the options for the first step were 2, the possibilities for the first step were 2, and 2 possibilities were there for the second step. When we looked at the all possible outcomes or the total possibilities, we saw that there were 2 times 2, that is 4 possibilities. Similarly, if we take any other simple experiment, like maybe if I'm traveling from my home to some fixed destination, having a step in between the journey, and I see that my travel from home to that destination is divided into 2 steps. The first step is traveling from home to this stop, and then traveling from this stop to the fixed destination. And I know that for the first step, when I am traveling from the home to the stop, I can have 2 means of transportation. That is, either I can ride on my own bike or I can have a public bus. Once I reach to this stop, the next options that I have for traveling from this stop to the fixed destination, I have either I can go via car, or I can hire a cab, or I can walk the remaining distance. So if we talk about all the possibilities, all the possible ways in which I can travel from my home to this destination, I would say that by taking first the bike, then I have again 3 options in front of me, that traveling this much distance with my bike, I further can take car, or after bike I can have a cab, or after going with bike I can walk the remaining distance. Similarly, if I chose to go through bus for the first time, for the first step from my home to the stop, then I can get a car. Again, leaving bus, I can hire a cab further for the further distance, or after bus I can walk the remaining distance. So here if we see, the first step had 2 options and the second step had 3 possibilities, but in total, when we talk about the total possibilities, they are 2 times 3, that is 6 possibilities. So the same thing is stated in the counting rule for multiple step function, or multiple step experiment, not function. I don't know why the function is getting involved all the times. This counting rule simply states that if your experiment operates in multiple steps, in more than 1 steps, in 2 steps, in 10 steps, in 100 steps, or maybe in 1000 steps, and for each step you have some particular number of possibilities. Your first step operates or runs or has some number of possibilities, the second step has another number of possibilities, the third step has some different number of possibilities, and so on and so forth. In total, the total possibilities would be the product of all those possibilities for individual step. I would write the definition so that you can have an idea of it. simply says that if your experiment can be carried out in some k steps, it can be carried out in 2 steps, 3 steps, 10 steps, 100 steps, or many more, and each step has some different possibilities for it. Your first step can give you n1 outcomes, the second step gives you n2 outcomes, maybe 3, 4, 5, 6, 7, 8 outcomes, or 100 outcomes. Similarly, your kth step of that experiment can give you some nk number of outcomes. Then the total outcomes possible for that experiment would be just the product of all those outcomes which are possible for each individual or respective step of your experiment. The next counting rule that we need to learn for the things when we are assigning probabilities to the experiments or their outcomes is the combinations and permutations. Simply talking about the things when we are meant to choose things from the existing objects, or we are making to select some objects out of the total available objects. So when we are going to read or learn the counting rules for combinations or counting rules for permutations, I would say that they are not much different. Okay, they are different from one another, but the simple or the prime thing is that in both the cases we are making some selection. We are choosing some objects out of other objects. While we say that we are dealing with combinations, we use the notation like this, some n, c, n, or write n, c, k if you are not happy with small n and capital N, or we say that n. In both the cases we read it as n choose k or n choose k, that we had total of n objects and we selected some k objects out of it. Similarly, when we are talking about permutations, we say that n permutations k. This notation we usually use for it. Now, what do we mean by this thing, or what are the difference? What is the difference between those two things? Here, when we are choosing k things out of the total n things, we don't worry about the order of the selection. If we choose in any order, it's considered as the same thing. Let us deal with it with an example so that it makes more sense. So for example, I have a total of 5 objects and I am choosing 2 objects out of it. Let us give name to those 5 objects, as I have some A, B, C, D and E objects. And I am trying to choose any 2 objects out of these 5 objects. So my selection when choosing 2 objects out of these 5 would be either I would choose A and B, or I may get A and C, A and D, or A and E. These can be the options. Or I may have B and C, B and D, B and E out of these 5. Like out of these 5 objects, I can have any pair of 2 objects which I have written or I am further going to write. Or I can have C and D, or C and E objects, or I can have D and E objects. So these are the total possibilities that when I am selecting a pair of 2 objects out of these 5 objects, I can have any of these pair. So these are the all possible outcomes, which are some 4 plus 3, 7 plus 2, 9 and 10. Some 10 possibilities. So I would say that choosing 2 objects out of 5 objects can be done in 10 different ways. There are 10 possibilities that I can choose 2 objects out of 5 objects. I don't know if it is visible or not. Stop correcting.